Welcome back to Matt's Playground. So today we'll be doing a quick review of exponents. First question. For all of the following, find the number x that makes the equation correct. A. 2 to the power of x is equal to 2 to the power of 5 times 2 to the power of 9. So as we did before, and hopefully you remember that if you have the same base, and two exponents, you can add the exponents, but this wouldn't work for different bases. Okay, so then we end up with 2 to the power of x is equal to 2 to the power of 5 plus 9, and since we have the same base on both sides of the equal sign, we can cross them out, and we're left with x is equal to 5 plus 9, which is equal to 14. Okay, on to b. So, in the parentheses, we have 4 to the power of 3, all of that to the power of 7 is equal to 4 to the power of x. So we can rewrite it as 4 to the power of 3 times 7 is equal to 4 to the power of x. And we have the same bases again, so those cancel out, and we're left with x is equal to 3 times 7, which is 21. Okay, now c. 5 to the power of x is equal to 5 to the power of 9 divided by 5 to the power of 4. Like we did in A, instead of adding the two exponents, we get to subtract them. So we have 5 to the power of x is equal to 5 to the power of 9 minus 4, which gives us x is equal to 9 minus 4, which is obviously 5. Okay, and I promise these will get harder. Okay, next two questions. Find whole numbers a and b that make the equation true. 3 to the power of a times a to the power of 2, all of that in a parenthesis to the power of 5 is equal to 3 to the power of 15 times a to the power of b. So we end up with 3 to the power of 5a times a to the power of 10 is equal to 3 to the power of 15 times a to the power of b, which immediately gives us that b must be equal to 10. So since we have 3, so then we're left with 3 to the power 5a is equal to 3 to the power 15, which also gives us that a is equal to 3. Okay, next question. Evaluate the following equation. 32 times 25 times 2 to the power negative 2 times 5 by 2, all of that to the power of negative 3. Okay, so let's turn these all into exponents, so it's going to be a tiny bit easier. 2 to the power of 5 times 5 to the power of 2 times, we can turn 2 to the power of negative 2 into 1 by 2 to the power of 2 using one of our other laws, times 5 to the power of negative 3 divided by 2 to the power of negative 3. Okay, so we have 2 to the power of 5 times 5 to the power of 2 times 1 by 2 to the power of 2 times, we can turn this in again into 2 to the power 3 divided by 5 to the power 3 using yet again one of our other laws. So if we can cross out 2 to the power 5 and 2 to the power 2, so we are left with 2 to the power 3, and 5 to the power 2 and 5 to the power 3 gives us 5 in the denominator. So we're just left with 2 to the power 3 times 2 to the power 3 divided by 5, which gives us 64 divided by 5. Okay, it did get harder. See, I do keep my promises. You can trust me. Okay. Next question. Evaluate the following. A. 7,056 to the power 1 by 2, which is the same as square root of 7,056. So, first, we are going to start by finding a range since this number is pretty big. So I know that 100 squared, we know that 100 squared is obviously 10,000, but that is too big, right? So now if we do 80 squared, we're going to end up with 6,400, which is too small. So let's try 90 squared. So 90 squared would give us 8,100, which is too big, but still, now we know the range. It has to be in between 80 and 90. Okay, so we have our choices: 80, 81, 80, 82, 83, 84, 85, 86, 87, 88, and 89. Okay, so obviously, since we have 6 in the ones place, we need to find a number from all of these numbers that if you multiply the ones place, you get 6. Okay, so we only have 84 and 86 as options. And if you do calculate it, our answer would be 84. Okay, last question for now. 4 to the power of 5 halves. So we can um we can rewrite this as 4 to the power of 1 by 2 times 5, which is equal to 4 to the power of 1 by 2 is 2, so we have 2 to the power of 5, which is 32. Okay, so that was our last question. Okay, I don't want to I don't want to end this with a boring question. So how about we end with a fun fact? Are negative 3 in a parenthesis to the power of 5 and negative 3 to the power of 5. So basically our negative 3 to the power of 5 and um and negative 3 to the power of 5 the same. Why or why not? I'll give you the answer. Yes, they are. Since 5 is an odd number, for the first one, negative 3 to the power of 5, this one, we have negative 3 times negative 3 times negative 3 times negative 3 times negative 3, which is surprisingly equal to negative 3 to the power of 5, which is the second one. But if we had negative 3 to the power of 4 and negative 3 to the power of 4, we would, for the first one, we would have negative 3 times negative 3 times negative 3 times negative 3, which is 81. And the second one is negative 1 times 3 to the power of 4, which is negative 81. So they're not the same. So this tells us that if the exponent is odd, they are the same. If the exponent is even, they are different. Fun proof. Well, it's logical. See you next time.